uh, Molecular Imaging Department at Sindh Institute of Urology and Transplantation. Moving toward the introduction, that the detection and measurement of radiation is an essential tool to take proper protection measurement, for which many types of the detectors and monitoring devices like survey area meters, personal dose monitor, etc. For personal dose monitoring, OSLDs and TLDs are used to measure radiation dose to the radiation workers. And TLD, basically, as you all know, the TLD batch materials is from the lithium chloride, doping of the magnesium, copper, and phosphorus using heat exchanger. And OSLD is based on the principle similarly to that of the thermal imaging dosimetry. Instead of heating, light from laser is used to release the trapped energy in the form of the luminescent consists of carbon dope. Uh, for the purpose of protection of radiation workers, the general public from these man-made radiation generating device and source, the imperial rules of radiation protection, that is TDS, time distance shielding, spending less time in radiation area, maintaining distance from a radioactive source, and placing appropriate shielding. PNRA has implemented operational dose limit 20 millisievert for radiation worker of Pakistan adopted from standard and guidelines IAEA and ICRP. Basically, the aim and objective of my study is to evaluate the amount of radiation dose of Parker measured by dosimeter using OSLDs and TLDs to the acceptable limits of 20 millisievert per year, and also compare the dose constraint, which is set to be 3 millisievert per year in nuclear medicine molecular imaging, and also evaluate the trends in the radiation dose received by occupationally exposed personnel of SIUT, NM, and PET-CT facility for the year 2017 to 20 period, and to eliminate any option that would lead to an annual individual dose greater than the set of ICRP dose limit using PNR and IAEA and radiological protection measures needed to meet the optimization principle. Basically, the material and method which I use, thus my research assessment is a retrospective study to assess radiation personal dosimeter practice um, in nuclear medicine PET-CT received in the year of 2017 and 20. And this assessment also correlate the past result of dosimetry reading using TLD and OSLDs for the PDP at SIUT nuclear medicine PET-CT. The deep dose equivalent whole body exposure dose was converted from milligrams to millisievert, and the dose, a control dose reading was digitized for each year. The readings were analyzed manually to the dose limit and recommendations were made. Now you will see the readings using the occupational dose of worker with a minimum maximum average dose and a time period in the workers of attained the limits of 20 millisievert. This is the result. There was completion of 20 millisievert and 3 millisievert limits of the dose constrained by worker. Now moving toward the result and discussion. The result shows that the average annual dose of worker in the year of 2017 using TLDs were 1.140 millisievert when using OSLDs. The average annual dose were the year of 2018, 19, and 20 was 0.456 millisievert, 0.234 millisievert, and 0.315 millisievert respectively. This dosimeter reading were decreases yearly as this that shows you will see in table also the good practice mental dose constraint as well as annual dose limit. This is the result which I demonstrate. All worker dose reading will gradually decreases in the air. And limits, this is the limit of 20 millisievert and slash 3 millisievert. Now, conclusion is that from the annual dose of our data of year 2017 to 20 of all radiation worker of SIUT in the Department of Nuclear Medicine, PET City, the radiation doses of all radiation worker were in the acceptable range of PNRA and ICRP organization, which verifies that the facility for radiation protection are adequate, and it is essential that institute that perform activity and training workshop exercise involving radiation exposure and practices accumulate to keep the dose and using alarm principle. Thank you very much.